Hello, everyone. Welcome to ThinkTech's virtual meetups for the summer season, an initiative organized by the Saudi Ministry of Communications and Information Technology. ThinkTech aims to create a stimulating digital environment and to spread digital awareness about emerging technologies. In this optic, we are happy to introduce you to a series of meetups focused on emerging technologies. Today, we have the session Advanced Analytics and the Next Normal. Your moderator is Tom Isherwood, partner at McKinsey & Company. Tom supports government clients on topics related to economic and fiscal strategy, government transformation, and data and analytics in government. He has served public sector institutions in more than 15 countries on these topics across Middle East, Asia, and Europe. Tom, the floor is yours.
Thank you. We're very excited to be here today and excited to be part of the ThinkTech initiative. With me is Tamim Saleh, Senior Partner at McKinsey. Tamim, may I ask you to introduce yourself, please?
Yeah, thank you, Tom. My name is Tamim Saleh. I'm a Senior Partner at McKinsey based in London. I co-lead McKinsey Analytics, and also I lead McKinsey Digital in Europe. And my background is analytics and data science for 25 years, and very happy to be here with you today.
Great. So the topic today is advanced analytics and the next normal. This is a topic that's interesting for many people with technical backgrounds, but also people without technical backgrounds. And so I thought it might be helpful just to get started with clarifying what we're really talking about. And so people say, we talk about advanced analytics, we talk about AI, we talk about machine learning. Tamim, how should we think about these different terms and this topic?
So Tom, there's a lot of hype about what is advanced analytics, what is machine learning. And to give you an example, I recently asked 50 of our geeks to define what is machine learning, and I got 50 answers, which are not all identical, yeah? But having said all of that, there are agreements, yeah? So advanced analytics are using analytics techniques that significantly improve prediction power. Analytics techniques, for example, like using hundreds of variables and correlating these variables to the question that you're trying to answer. This question, for example, could be, would this customer default on payments if I'm a bank? Also, advanced analytics uses techniques which are very advanced software that allows you to run complex processing for prediction. Advanced analytics also use mathematical models like clustering and so on, which are much more sophisticated than traditional linear models. All these things add up and give you much higher prediction power. I'll go quickly through what is AI and what is machine learning and what is deep learning, because again, a lot of people talk about that. So AI actually is quite old. It's even before I was born. It's in the 50s. And basically, the word AI, which is artificial intelligence, there is no real intelligence actually in how machines work. Machines are incredibly powerful computational entities that you use. So it's much more about calculating probabilities. But the machines improved so much and the software improved so much that the power of these techniques give the impression that, that the AI is solving a problem that requires thinking. This problem, for example, could be understanding text or a paragraph, or understanding, for example, what would be the action if A and B is like this. What would be the action that we would do, the logical action? And that's why we use the word artificial intelligence. Machine learning is a process where if, for example, there's an artificial intelligence predicting program, let us say predicting program for the probability of fraud of a transaction, for example. Machine learning will check over thousands and thousands of situations where the predictions have happened, what was predicted and what really happened, and then it will gradually improve the quality of correlations or the program itself, so you get better predictions. Machine learning is extremely important because as it becomes automated, you can improve the quality of an AI program, like, for example, the driverless car. And then finally, deep learning. Deep learning are techniques that, imagine, for example, you have a program that needs to recognize my face. So a deep learning program will have like 100 different software layers, one for my nose, one for my ears, one for my eyes, and then it combines a complex problem to be able to solve it much faster rather than the traditional software techniques. Again, deep learning is very useful for complex problems that use image and so on.
Thanks, man. I think this is a good basis for the rest of the conversation. I think we'll start to get questions from the audience. But before that, I had one or two questions of my own. The last 9 months have been a really tumultuous time for the entire world. And data has been more important than ever. How have executives been using advanced analytics to navigate this crisis?
So, as we all know, it's very unfortunate what has been happening. This is a real tragedy for people across countries and across the world, COVID. And a lot of companies have been under enormous stress. Companies depend on the industry, obviously, but some companies lost 80% of revenue, even more. Some companies, for example, they have not been able to have the staff on site or in the mines or in the oil rigs and so on. So executives had to react. And we actually wrote a paper recently about this, of course, in McKinsey. We looked at 200 companies to learn from how they applied advanced analytics in the crisis. And there were some patterns. One key pattern is that a lot of companies became extremely pragmatic. So traditionally, for example, a lot of the executives would want the perfect data before you run analytics on it, or they would really want the systems to be working very well, the technology. But no, there was no time. So what companies have done is that they prioritized the key opportunities that they need to address, or the key threats. They got the resources against that, and they accepted, for example, if I have data at 80% of what I want, I'm going to run the analytics on it. And most importantly, they have changed the way the organization works. So they got teams to look at end-to-end at what the key processes are, and they gave them power to make decisions. And in that paper that I mentioned, Tom, we showed examples in different industries. Like, for example, there's a story in a mining company that were able in 6 weeks to have a team that got data from 40 different mines and then do cash flow analysis, scenario analysis in real time, when it used to take them 5-6 weeks. We talked about an energy company that was able to very rapidly get a team across all the products to manage campaigns and pricing. And what they used to take them 8 weeks, they were able to do it in a matter of few days. So to answer a question, I know I gave you a long answer. In a crisis, actually, a lot of companies demonstrated that you can use advanced analytics in a pragmatic way very rapidly, but that required a different way of thinking, and it required empowering teams to make decisions and creating nerve centers and so on.
It's good to hear how this has made a difference over the last 9 months. If we look forward to the next normal, to whatever is kind of coming after this crisis passes, how do you think the role of analytics will change, or how will this evolve going forward?
I think there are definite changes. So people are not going to go back to the old ways in certain ways. Yeah. So until 9 months ago, or when COVID started, so let's say from November onwards, December onwards, because it started in Asia, of course. A lot of companies saw analytics as a strategic opportunity, and it takes a long time, some of these projects. And then, of course, when COVID crisis came, many scenarios where companies were able, within a matter of weeks, to implement analytics solutions. And there are 4 or 5 things that I think companies have learned and likely to stick with. First of all, you don't need perfect data to get good prediction. I really stress that point. There is always an assumption that the data has to be perfect. To give you an example, you can make a perfectly good prediction about the likelihood of for example, a manufacturing line delivering to target with 10 to 15 variables, not 500. Of course, the more you have, the better, but you don't have to have perfect data. The second thing they've learned from this is that you need to work differently. The operating model, the human side, is different. Traditionally, a lot of government organizations or private sector would have departments and silos. So you might have, for example, teams working in the finance department, another one in human resources, another one in supply chain. What they've learned in COVID is that if you get teams together across these silos and make the data available to them and run analysis or analytics on it and give them the power to make decisions, things to move much faster. So to give you an example, one retailer in the Middle East, actually, they got their teams from different product groups, and got them together, a team of 8. And within 4 weeks, the category and product data became available to them. And the idea was to make sure that the top 100 products are available. These teams were able to make decisions and reduce the problem from 30% of products not being on the shelf to 100% availability. And they were working across silos, and they were enabled. So basically, in the long term, many companies will simplify their organization by breaking these silos and giving teams ability to make decisions. And then the third thing that I think will not go back to normal is that the new working model, in fact, many teams became more effective when they worked remotely. And I include here even software development and running analytics and so on. So a large number of companies will seriously consider, do I really have to have that model where everybody should be there physically, or can we get a model that works better? And then finally, the technology. Traditionally, a lot of the analytics, people assume that you have to do, for example, an end-to-end ERP implementation, or you have to spend 12 months improving the software architecture and all that. Actually, they found that there are solutions that could be on top of ERP, and then you can ingest the data on these applications and then run analytics for 10% of the effort, but 90% of the value. So in summary, the operating model will change, KPIs will change, and people will have the ability to make decisions. You will see a lot more of nerve centers, whether it's in marketing or supply chain or HR. People will be a lot more pragmatic about technology and quality of data. And finally, you will see a lot more of remote working. There are many examples of organizations now that reducing their full-time on physical location staff by 30%. 30% is about the number that we're seeing now. There's big changes.
We have a question from the audience, which is related to what you were just talking about. Question is, how can silos between departments or government entities be tackled in order to provide better data? And do you have examples of actually how organizations have gone through these changes?
Absolutely, both government and private sector. I'll give you an example which I saw in the United States, where the local state authority needed desperately to have data around hospital capacity and being able to do containment of the virus across counties. And there were different departments within each of these counties, and at the state level, they all had different data sources and so on. And basically, they got a supplier that and they created a nerve center that represented the state and the counties within the state. And they agreed among themselves, and this took 2 weeks. The supplier provided a data lake architecture, or let's say the cloud platform, where you can ingest that data from the different counties. And within a matter of 4 weeks, they had an up and running platform across all the silos. The silos in this situation are counties and subset of the state. This is not federal, this is within the state authorities. And they agreed basically on roughly 100 information points around hospitals and schools and doctors and capacity, and then gradually increased it. And it was incredible. The nerve center had 12 people. That's all they had, representing, the entire state. And they were able to run, that nerve center was able to support the entire silos in the government department to make decisions around where do I prioritize my resources for PPE or for doctors or to support in ambulances and so on. And the example that I just described to you, you'll see a lot more of it. It could be, for example, within a Ministry of Finance, it could be within education, it could be in a private sector. You find the problem that you're trying to solve. The problem could be, for example, in this case that I mentioned to you, was capacity management to contain the virus, whether it is hospitals or whatever. You identify the data required, you create a team that looks end-to-end, and that team tends to be small, and then you define the technology and you ingest the data, and the team has an end-to-end view to provide the insight. You will see this a lot more. It's happening in the private sector. In the paper that we did, Tom, which I mentioned, we gave examples in supply chain, in marketing, in sales, in manufacturing, and you see this in government as well.
One of the other questions we got is, how much is too much when it comes to the size of data? Are there problems we're running into now just because of the volume of data that's available?
Yeah, I think the volume of data is less of an issue unless you are addressing something of massive, massive complexity. Yeah. Why I say the volume of data is less of an issue? The volume of data is less of an issue because storage cost is actually like 2% of what it was 4 or 5 years ago and continue to go down. Bandwidth issues, of course, in real time. So if you are trying to, for example, analyze image with a camera in a plane, for example, in real time, that could be an issue. But even that, there are now techniques like data compression that allow you to a massive processing power that you can address that. So the real issue is not volume. The real issue is the variety of data and the different sources of data. So if you are, for example, a government department and you have 20 different systems, each system, uses different data model or cataloging, different rules, and then you're trying to get the data from these different sources to serve the citizen or the customer, then it becomes harder. So it's not a volume issue, except for extreme scenarios. Most of the time, it's not a volume issue. Most of the time, it is sources and standards and variety. That's where the problem tend to be.
How are the tools to deal with this kind of data evolving?
This is, at least people like me get very excited about it, yeah, because everybody gets excited about artificial intelligence and machine learning for growth and use cases around the customer and so on. But actually, there are tools now that use artificial intelligence and machine learning to recognize the data, which is called data discovery, where actually these are tools that you can train the model. The data engineer can actually train the model in that tool to identify, for example, citizen data in this 20 or 30 different data sources or 30 different systems, and then extract that data in the right standardized form in, for example, the data lake, where you could then run advanced analytics on it. And then there are tools also that allow you to do the software development, called software 2.0, where the vast majority of the effort that traditionally would have been in a manual to actually do the software development for analytics is automated. We are heading basically in the next decade where the process that we do now, which requires a lot of human skills and human intervention to get access to the data and ingest that data and standardize it and then do software development to develop solutions for AI. In the next decade, 80%, maybe even 90% plus of this cycle will be automated.
So, to me, we've talked a bit now about how different companies in different sectors have used analytics over the last 9 months. And we've talked a bit about some of the tools they're using and how just the amount of data is increasing. I want to bring this to the individual level for a second. How does all of this affect you or me as consumers and maybe employees in an organization that's using analytics?
So let's start with the employees, and then let's talk about the consumers or people at the receiving end. At the moment, people who use analytics tend to be geeks, let's say. Yeah, I use this word carefully. I can describe myself as a geek as well, who are really experienced with the technology and they understand how does it really work. Yeah, whether it's the mathematics and so on. I just mentioned, of course, just a few seconds ago, that the process of accessing the data and ingesting it and so on, and developing solutions would be highly automated, which means that you genuinely democratize the way people use analytics. In the next decade, that democratization process for employees will continue. The more that you can automate the cleansing of the data and the making it available, and the more that you can automate the process of developing a solution or a use case, the more that the average person will be able to use the data. So that's one aspect. The other aspect is that a lot of companies recognize that education is needed to their employees. So there are many examples. To give you an example, a European bank, they are training 3,000 employees to become translators. That word translators, you'll hear a lot of it in case you have not heard yet. I'm looking here to my audience. Translator is somebody, could be in marketing, in sales, in HR, in whatever, or could be in public sector. These people, translators, are people who are literate. They understand how analytics work. They can work with, for example, a data scientist and data engineers to develop an analytics solution for the department they work in. So if I'm working, for example, in customer service, I could be trained as a translator. I understand how a data scientist develop a model. I work with them. I can translate to them my business expertise so that they can create the mathematical model that will help me. And over time, you will see maybe 5 to 10% of the population of typical government departments or private sector companies who are literate. They are not data scientists, they are not geeks, but they know how to work with them to utilize the data. And this is already happening very rapidly, especially in the private sector, but the government sector is beginning to do that. You combine that with the automation that I've just mentioned, and you really begin to get that democratization of usage of data.
How about for consumers on the receiving end?
Consumers are already beginning to see big changes in terms of how analytics help them. So, I mean, think, for example, of I mentioned the driverless car as an example. Well, it's actually running by real-time machine learning techniques, right, to actually have a driverless car. Or think about, for example, if you are applying for a consumer loan in a bank, why would you be able to get it in real time? Because it's a program that is running there. Or when you are traveling, let's say away from your country, and you are worried that fraud might happen to your credit card, there is real advanced analytics checking, for example, your mobile phone versus your credit card. Are you where you are? There are thousands and thousands of applications. A lot of them are for good. I mean, take the government sector. I'm extremely impressed with some countries like Sweden and Norway, how they're using advanced analytics for education, how they're using advanced analytics to find our programs they have, for example, in Sweden, where the system monitors the style of the individual student in learning a subject, and then the system helps the student to get the most relevant exercises and even the teachers that can fit with that student. So we will see as citizens and as consumers thousands and thousands of applications of advanced analytics that are relevant to us, and it will make our lives easier. And I think maybe some of the audience who are in this discussion might be wondering, is it really going to replace us as employees? And so far, in the vast majority of situations, what advanced analytics have been doing and machine learning is replacing the repetitive tasks. What I would describe as something which is repetitive scenario, and then allowing us to focus on the intelligent tasks or the creative tasks that requires humans to make a judgment. I don't see in any time soon that it will replace us. I think actually, if anything, it will help us to be much more human, and we can take judgment, while the repetitive tasks, we use the systems for that.
One of the questions we got from the audience was, for those who are not geeks, what's the best way to get onboarded or to learn more to be able to use advanced analytics?
Yeah, so I mentioned the word translator training. Yeah, translator. I mean, to give you an example, in McKinsey, by the way, we do translator training to our people as well. It's the idea of a translator training is to be literate. I said the word literate. It's 5 days actually training. This is the McKinsey example. Many other companies do that as well. And these 5 days allow you to understand what is analytics, what are the statistical models that are applied for prediction, what is the technology that enables this, how do you make analytics impactful in real life? Because believe it or not, 70% of the problems that causes analytics not to be effective is human. Organizational issues or cultural resistance. So the non-geeks, you could find it in your organization. If they are doing it already, then you should get that kind of training, and that will allow you to know how to work with the geeks or with the data scientists to get the most out of them. If your company does not do that, or your government organization, there are lots of online training with the most famous, I won't mention any names of brands, but believe me, you will find it. equivalent to about 80 hours of your own time that would give you good judgment. Yeah, but I would not suggest that you spend 6 months deep dive and all that. I don't think that's what you need if you are, if your objective is to understand how to get value from analytics and how you could work with the data scientists and so on.
So to me, you've described what this will mean for employees, which is we'll get to do more of the interesting parts of our jobs and less of the uninteresting parts. You described what it means for consumers. There will be better service. A lot of times we won't even see it, but better service that we'll receive. This all sounds good. Are there risks, or is there a dark side we need to be worried about?
So of course, I mean, analytics is like anything in life. Yeah, if you give somebody a car, yeah, somebody could be a very safe driver and goes from A to B. You give the car to somebody else, and they could have accidents and hurt themselves and others. Analytics is no different. And the good news is, let me, to answer your question, I'm giving a bit of a lengthy answer. The regulators in different countries are becoming really, really experienced in how analytics work. And I talk to a lot of regulators to protect privacy, to protect people's rights. And they are working very closely from the United States to the UK to Europe, and it's happening across the board. But having said that, of course, there are risks. Yeah, and I'll give you an example. I know of a company where they developed an analytics use case that was predicting absenteeism, where what is the probability of people in certain part of the organization being sick leave or not coming. Now, the objective of that analytics model was not to target the individuals, not at all. The objective was to find the conditions in the company. For example, is the factory causes people to get back problems? Can we work with the managers to improve the situation? And actually, when they applied these techniques, they really helped to reduce sickness of their staff and improve the conditions. I have seen exactly the same model where I was talking to another company, and they wanted to use the same model to target individuals. And I said, you cannot do that. Yeah. And actually, they found that the regulator would not allow that. So it's exactly the same algorithm. So the point I'm saying, in the end, we humans make decisions in terms of how to use a car or a tool, and we need to make sure that we do not forget our values. And the regulators understand that. So the private sector and the public sector are working very closely with the regulators to make sure privacy and data security and all that is being addressed. But I'm not naive. There will be, of course, situations where people will abuse it. And we have to work very closely to make sure as leaders or individuals or citizens that when we see that, we stand up to it.
One of the questions we got from the audience is around the link between analytics and decision-making. How does this support decision-making? How much does this replace decision-making? What kinds of decisions will we be making with these models?
So many, hundreds of situations. Yeah. So I'll give you 2-3 examples of how it can help decision-making. So I had a client where they are in the steel industry, and the demand to forecast demand from the customers are like big automotive companies and so on. They have to supply steel to them. It's very difficult. They use basically gut feel and experience of their forecasters, but they have to increase their inventory so that they can always meet demand. That inventory costs them 250 million euros a year to have that additional product. Then they started applying advanced analytics where they were looking at hundreds of scenarios, hundreds of variables, and it improved their prediction by 15%. They were able actually to predict demand fluctuations better by 15%. And it was man-machine, human-machine. It did not replace the forecasters, but it was a supporting tool. It reduced the 250 million cost to 50 million, 50, from 250 million to 50. There are many examples where better prediction enable us to make better decisions, whether this is about, for example, mortgages, consumer loans, improve team performance. There are, for example, many analytics programs that can help you get a prediction of what is the best mix of a team so that they can deliver a program. I mentioned demand planning. quality control. I can go on and on, hundreds and hundreds. Anything that requires prediction and you can support it by data and correlations, you will use analytics in it.
We're getting actually a lot of questions, some that are very theoretical and some that are very practical. I'm going to take one of the practical ones to build off of what you just said, coming back to the notion of different tools that are available. Without recommending a specific brand or a specific tool, how do you think about the whole world of tools that are out there? Tableau, Alteryx, Power BI, there's so many different things. I mean, how do you make sense of the different options, and how would you suggest that people in the audience think about the different options?
Yeah, so this is an extremely, and I'm really sympathetic to CIOs and business people and technology people and people in the government sector, because it's a bit confusing, plus all the hype which is there as well. So I'll try to, in like 2 minutes, give you an answer that I could talk about it for 2 days. Yeah, essentially, there are hundreds of tools that allow companies and government sector to capture data, ingest it, run analytics on it, and so on. Some of it are from the existing vendors, yeah, the famous names that you would know, and some of it are open architecture based. Yeah, open architecture like Hadoop, etc., where it's available. There are some companies that put it together and make it available to people, but still it's open architecture. And the truth is, if I give you just rough speaking, the majority of large organizations are probably doing a bit of both. So they're using their existing systems to clean the data in these systems, ERP, for example, and then a lot of their suppliers already provide analytics tools that you can put on top. But in addition to that, in parallel, they tend to get open architecture. I mentioned Hadoop, Cloud, Era, this type. They have it in parallel, and then they ingest the data, especially if there's a lot of storage required because it's cheap to do it in this open architecture, and then run analytics on it. So we are gradually seeing a scenario where companies have both using or cleaning the data in their core existing technology, and then they're having parallel open architecture or similar technology where they can run heavy analytics on it. It's not the only way, but I'm just giving you a feel. And there are many, many different layers, but if I had to simplify it, maybe 5 or 6 layers in the technology in relation to analytics. One is the cloud platform infrastructure. Cloud is very important in analytics because you can get data from different sources and store it and run analytics on it, make it accessible. So cloud infrastructure is one. Then there is, and of course, cloud infrastructure, you have all the famous names that you can, I mean, you know them, AWS, Microsoft, Azure, Google, the usual players, IBM, so on. And then there is, on top of that, the data integration platform. Data integration platform is the software or technology that allow you to capture the data, and then you get that data in an organized form where you can run analytics on it and you can manage it. And it will have, on top of that data integration platform, you will have things like machine learning tools, visualization, so you can see it, yeah, access, security, all that. These tend to be, you can buy these or you can have them as open architecture. And then on top of that, of course, you've got the channels, which is the access to data where you can see it. And then, of course, beyond all of that, you've got the enabling network infrastructure. But I know I gave you a long story. Essentially, there are hundreds and hundreds of players. But if you think about it, if you want to remember from what I've said in the last 3 minutes, the majority of companies are still using their existing technology to get the data in a clean form, etc. But in parallel, they are building technology that allow them to run analytics and visualization, not to replace, but in parallel.
We're starting to get some questions that are focused on specific domains or specific sectors. And so I'd love to go through a couple of those. The first one is from a self-professed GIS enthusiast and wants to know, how often do you find that location is a really important variable or an important factor in analytics that you're doing in different sectors?
You mean location of the country or the user, or?
No, like the spatial analysis, like the GIS component.
Okay. So well, super important. I mean, the world has changed so much. I have teams that are working in projects where for companies and including public sector, where you can get location analysis in real time of what is happening within 30 meters, for example, 30 meters radius of a store. And of course, that enables you to do enormous amount of, so example, there's a team in McKinsey working in Eastern Europe with a company that has about 4,000 stores. And the company can get in real time through apps and people's mobile phones. These apps can help in real time to know, without obviously pointing the individual. These are because you have to protect the individual, but can tell you, for example, that this is the crowd movements in that location within 30 or 50 meters radius. Then the store, according to that, they can define their pricing model, their supply chain, their promotion. Location analysis is relevant to hundreds of situations. Another one I can tell you is mining. I was in the mining site last year in South Africa, and I saw in the mine, this is open mine, you've got big machines moving. Some of them are driverless machines, huge trucks. And there's a safety advanced analytics and machine learning software that if you look at the screen, you see lots of dots. These dots are humans, and then larger dots, which are the movement of the trucks. And it's location analysis, again, using visual, or what people describe as image analytics. So there are cameras that can see where people are, where the machines are, and in real time calculates the movement. Is there any risk to people? Are they moving in front of a driverless car, or are they going the wrong place? And it's location. So these things, you'll see more and more of it. It's incredible, actually. And it's a combination of GPS technology, image analytics, and so on. And it's cheap. It's becoming a lot cheaper to use.
One of the sectors that people are interested in is healthcare. Of course, given the events of the last 9 months and the COVID-19 crisis, this one's top of mind. What is the role of analytics in healthcare, and specifically in preventing disease?
Huge. I mean, that's simply the answer. Yeah. I mean, you've seen in the situation we have with COVID, analytics will become more and more important for containment of the virus, and hopefully beyond containment and prevention. And there are, as you know, the tracking, for example, models that different governments are developing. The tracking models will continue to increase in sophistication. And I have no doubt the time will come where within a matter of minutes or seconds, you could get, for example, a warning in your mobile phone that you have been within 5 meters radius from somebody who is positive. Yeah, or because it's a combination of testing and tracking and using analytics to help us. Also in virus containment, being able to define what is the optimum way to locate people at a micro location level. So for example, if a city does have a breakout, how do you address that? Analytics is going to be used in all of this. And of course, there are many other examples beyond COVID. I mean, we know, for example, that there are machines now that can recognize if somebody has lung cancer or lung disease more accurately than the doctor recognizing it in the X-ray, because of millions of similar situations. But I stress, I really don't want to leave a message to leave people thinking that these machines are going to replace us. In most cases, it is human-machine combined decision. Really important to highlight that.
One of the questions that came was around challenges. Clearly, not every example of advanced analytics works. For the ones that don't work, why not? What are the most important challenges for us to keep in mind as we're doing this kind of work?
Yeah, so it might surprise a lot of people listening to this chat that you and I are having. If I could talk to you, I would have asked you, guess what percentage of pilots, analytics pilots, don't actually deliver? The number is 80%. So even now, we've been years now applying analytics. 80% of pilots that companies would do, or proof of concept, they find it difficult to scale it and productionize it. And Tom, again, you may remember myself and two colleagues wrote about this last year in the Harvard Business Review. And we, in that article, we highlighted that the biggest challenge was cultural challenge. It was not technology. The reason that analytics, the challenge is sometimes in government departments or in companies, it is hard to scale because it requires a different mindset. So for a start, you can have a situation where the data is available to you to make decision. But if you are unable to make that or execute that decision, if you're not measured, for example, your KPIs or measurement system doesn't encourage you to take a stand on it, or if your boss is the one who has to approve it, but he really or she does not understand how analytics work, then it's not going to happen. And then, of course, if we talked about silos, to use analytics and make decisions, you need to have access to data across the silos, and you need to be able to act on it. A lot of the organization structures that we have nowadays does not help that. I mean, I've seen a situation with a company, and it was an energy utility, like electricity and gas. They were able, after they applied advanced analytics, to be able to make decisions to do pricing campaigns for their customers in a matter of hours. It used to take them 7 or 8 weeks, but they still couldn't do it, even though the program was up and running. The reason is that the campaign management team was separate than the marketing team, was separate than the analyzing team, and then they had different product groups. So the data is there, but the structure doesn't allow it to happen. And then finally, of course, and very important is talent. As I speak to you now, I would say, I don't know what's the latest numbers, but I know in the UK, for example, until very recently, the number of graduates who had the skills to do data science, and it's about 20,000 a year, but we need 5 times that number. And it's no different in other countries, US or whatever. So there's a talent gap, which we need to address. But having said all of that, things are moving in the right direction. Yeah. Yes, it is hard. Sometimes things are not delivered, but we are moving in the right direction. It's inevitable because the business case is so powerful to use it.
What are the 1 or 2 most important things for a leader of an organization or a CIO to make sure that they're not part of the 80% of the analytics use cases that fail?
I think if I'm a CIO and I want to succeed, I'll do the following. Yeah. First of all, work very closely with the business or the leadership of the organization. So if I'm working, let's say I'm a CIO in passport services, for example, government department, then work with the leaders who work directly with the citizens and understand what is the problem that they are trying to solve. Start from the problem that you're trying to solve. Don't start from IT. Yeah. Similarly, if you're in business, where is the opportunity that the business leaders see? And then that's point 1. And organize your teams to be working with the business, not separately. Don't do it bottom up. Analytics is not technology. Technology is an enabler. The vast majority of time spent on analytics is the problem that you're trying to solve. That's one. Secondly, I would be realistic. The talent is still difficult to get. It's taking time. Lots of organizations are training people. Lots of organizations having academies to train people on data science and translator and data engineering and so on. But it's going to take time. So get talent and concentrate that talent in where it matters. Don't just spread them because it's very difficult. So find the 2-3 domains. A domain, for example, could be production or supply chain or marketing or delivering a service if you are public sector. And get your best resources there and work very closely with the business or with the leaders to make sure that you deliver what is impactful. And then the third thing that you do if you're a CIO, do not assume that you have to have the perfect data. I hear this all the time, or the perfect technology. COVID-19 proved that pragmatism can deliver. There are so many examples. I mentioned we looked at 200 companies. There are so many examples that people were able to improve prediction power quite a lot with 80% of the ideal quality of data that you want and do it much faster. So be pragmatic. Pragmatism is very important. And then finally, start small. Make sure that the model works in terms of your team structure, the way you work, how you're delivering, and how you're scaling the analytics within a domain. And when it is really working, only then start scaling the organization. Yeah, but don't try it all, and definitely don't try bottom-up technology solution. For example, lots of organizations have been trying to clean the data bottom-up without knowing how it will be used, that is almost certainly not going to work.
Are there some kinds of problems that we shouldn't be using analytics for, or where analytics just doesn't work?
Absolutely. There is no need to over-engineer. So for example, if a decision that you need to take requires prediction of 70% level of confidence, by the way, lots of business decisions could be like that, or a combination of our judgment as humans and a little bit of data. Lots of situations in real life like that. You don't need to have the most sophisticated, machine learning, deep learning tool. So do not over-engineer. Understand. Start with the business problem. So, for example, mortgages in banking. Good example. The vast majority of banks, the average traditional linear methods, give them about 70% level of confidence when they look at all their default history and then correlations. That's actually not good enough because it requires, there will be defaults and so on. But do you need to do a deep learning model, which is extremely sophisticated to do that? Actually not. You can use forestry and certain other methods that can raise that 70% to 90%. And then you really have something which is very useful. So first of all, there are lots of problems that do not require super deep Rolls-Royce solutions. And then secondly, there are certain situations that analytics will not work. Analytics will not work if you cannot have data that allow you to correlate this data to the problem you're trying to solve. Whatever you do, remember, analytics in the end is statistics based. There is no intelligence. People say artificial intelligence. Artificial intelligence is what seems to us when a software helps us to solve a problem. It looks like they're solving a cognitive problem. But underneath all of that, it is statistics. And if you cannot correlate data to the question you're trying to answer, then don't waste your time.
On the topic of AI, one of the questions that came was around breakthroughs that have happened recently around the ability of AI to deal with natural language. What sort of opportunities and possibilities do you see coming out from this?
So obviously this is improving all the time. I remember when I was a much younger man, we were experimenting with this. I was working in a very large technology company. And in the labs, I've seen this, and it was very frustrating, put it this way. It is getting much better now. And I would say in the next 5 to 10 years, in a combination of software improvement, these software improvements will allow us to use machine learning and deep learning in a much more effective way in language recognition. And the combination of that will also be, I mentioned data compression techniques and so on, that allow us in real time to compute and analyze voice-based and language-based problems. And of course, processing power continue to improve. So many, many dimensions are coming together to improve the reliability of these systems. I think in about, I don't want to give you a number of years, but not too long from now, many of the problems that we use to type or to listen we will be using language. And it's actually super exciting. Because, to give you an example, call centers, imagine that there's a call center, somebody calls, they have an issue, immediately the system can recognize the customer or the citizen and able to look immediately within seconds at all the history and being able to extract these records to help the citizen in his or her request, or prioritize. By the way, these systems already exist. The systems can even tell from the voice if the caller is nervous or not, or uncomfortable, or stressed, or happy. All these things. So you'll see a lot more of that. And I think in the next 5 to 10 years, and actually combine that with image analytics, then it is very, very powerful. Very powerful, because you can have machines that can, for example, recognize risk in a construction site. And you're instructing these machines with voice. So these things are coming together, and it's extremely effective. Our understanding of computers at the moment, our current generation, is that it's something that you type in and you program it and it computes. our children, the way they would see it, a computer is like an agent that you speak to, sees you and analyzes you and responds and talks to you. That's where we're heading.
I think from my perspective, I never believed that would happen until this summer when some of the more recent breakthroughs happened. And a number of the news articles written about it were written by the AI, and you couldn't tell until the very end when they told you. And so interesting to see what happens here. On this topic, though, of AI becoming more sophisticated and in the future being, computers being more like agents we're dealing with, does this raise additional concerns or ethical questions? Previously you talked about the ethics of analytics and using algorithms. How do we think about that same question with regards to AI?
Of course, it raises, and again, we are learning the revolution that is happening in technology. With it, there's also a revolution that is happening in ethics in terms of how to deal with this technology, and in regulation, what data you should protect. And we have to learn. So I'll give you an example. Stories are always good. So in a European country, I won't say where, but because I'm not sure if it's public or not, there's a massive advertising board in one of the big squares in that European country. And in any given day, there's about 200,000 to 300,000 people who pass by that board and look at it. It's a massive advertising board. So the company that organizes this, they put cameras on top. These cameras recognize people's faces, and not who you are as an individual, but it basically recognizes your gender, your age group, plus or minus 5 years, and to a level of 85% level of confidence, it from your infrared and muscle movement, infrared temperature and muscle movement, it recognizes your sentiment, how you feel. So they are basically looking at, so when people look at an ad, actually the machine learning tool recognizes how they are reacting to the ad, and then you can change the advertising to get more excitement. So somebody found out that this is the case, and then they asked the regulator, who is keeping that data? Who's keeping my image? Who knows how I feel when I look at an ad? And where does this data go? Actually, the regulator did not have regulations to deal with this. It's not written anywhere. We have to address it. Who keeps our image? Who keeps our data? So to cut the story short, there are lots of questions that we are just beginning to come. And always the technology is about 3-4 years ahead of the regulation. This is what is happening.
One of the other questions thinking about the future and AI is, how will this affect different industries? Will there be industries that are made obsolete?
So AI is going to, or is making profound changes in a lot of industries, profound changes. So for example, if you are a company that, let me give you an example, insurance. So I was in China just before COVID. I think it was November last time. I go there regularly. And I was extremely impressed. One of the insurance companies in China, they have advanced analytics techniques where, based on real-time traffic conditions, they can predict where car accidents are likely to happen. And they will have their agents in the sites where the car accident happened before the police arrives. And then they will use cameras, and then they will make a decision on site immediately for the claim, so they don't have to go through this entire claim process in the back office. So they are killing their competition. There are hundreds of examples where people are beginning to use these technologies, whether this industry is banking or mining or insurance, and in government, it will be no different. We will have to change the way we work around the citizens. So yes, absolutely, it's a big impact.
So I like the way you put that. So what I understood is that actually we don't see this making industries obsolete, but we do see that the winners are using this effectively.
Correct. The winners are going to change the model that the industry operates in a way either to give them massive advantage in terms, for example, of cost and efficiencies, or the customer or the user find that it is so much easier to work with these people that they will work with them, or like have them as their suppliers and companies. And then in some situations, industry could even be completely disintermediated. So for example, third-party insurers will be under a lot of pressure, because if you have analytics techniques that can predict just as good as you are, then what value are you adding? So in some situations, you might even be disintermediated, or even traditional industries like retailing. Being a retailer that is purely physical retail in absence of understanding the digital channel and combining the two will kill you. You have to know how to combine the two.
Tamim, I think we have time for one last question, and it's maybe just to wrap it up. What would be your advice to people who are listening, who leave this discussion and want to implement advanced analytics in their work?
So I would say two things. We are, number one, this is so exciting. This revolution is incredibly exciting. What is happening here is history, guys. Yeah. We had like the humans discovered agriculture, I don't know, 10, 15,000 years ago. Yeah. Then we had the steam engine. Then we had industrial revolution. This is the next one, which is happening very rapidly. It will change our lives in an unbelievable way. And we are just at the beginning. You don't need to be a geek. You don't need to be a guru in programming, but you need to understand the principles. So I think after this meeting, if you take a commitment saying, for example, I am going to spend the equivalent of 100 hours in the next 6 months, whether to get training from your organization or online, understand what is AI, what are how does analytics work really? How do I use it in my business environment? There is a lot of information available online and elsewhere where you can make the effort to understand how it works. That's point number one. Point number two, then think about it in my business. Start from your business and not from forget about technology, forget about mathematics. But think, what are the 4 or 5 things in my job that if I have better prediction, it will make the job so much better for my citizen or my customer. If I'm, for example, in tax, how can I identify fraud taxation? If I'm, for example, in customer service, what is it that I could do using analytics that can improve the citizen experience? And once you know that, once you have a view, this is where you should target the analytics. Start from the business problem, from the problem you're trying to solve. This is the 2 advices that I would give.
Tamim, thank you so much for sharing your insights over the last hour. It's been a fun discussion. Also, thank you to the ThinkTech team. We're really excited to be part of this and are looking forward to the next ones. And finally, if anybody wants access to any of the articles that Tamim mentioned, I think we shared the links over the Zoom. If you're not on the Zoom, you can also go to our website, www.mckinsey.com, and you can find all of the articles there. Thanks again, everybody, for having us today. We really appreciate getting the chance to have this discussion with you, and thank you for all the questions.
Thank you.